Okay, hi class. So today we come to 10.7 complex numbers. Um, so in this section, we will talk about the complex number. Um, we we answer the question last time that I have tell you about negative of a square root. So um, say we are having right now a square root negative of 1 is in here we call it is a imaginary number which is an noted by I, and I will be equal to square root of negative 1. Okay, so remember last time I said a square root of a negative number or square root of negative 1 in here will not be a real number, right? So if it's not a real number, so what we're gonna call it? We call it is imaginary number. So it's noted by a letter I, and then I will be equal to square root of negative 1. Okay. In the form of the complex number, we will express as a plus bi. Okay, so a in here is a real number. Okay, a is real number. Okay, or a is real part, and b also a real part. A and b are real number, but we call a is real part and b is imaginary part. Okay, so let's say we have an example over here at 5 minus 3i, and we call the real part is 5 and the imaginary part is negative 3. See that? So again, number 5 is real part, and negative 3 is imaginary part. Okay. So now from now you can know that with a negative square root of negative something, say square root of negative 13, we can rewrite as I times square root of 13, which means the square root 13 in here is imaginary part. Okay, with I. Okay, and square root of negative 9 we can derive as square root of 9 multiplied by I, and that can be 3i, as you see over here, right? And 3 in here is imaginary part. Okay. Let's see if I can have some example for you. So again, complex number is a plus bi, and the real part is a, and the imaginary part is b. Okay. So let's do an example. Okay, give me 1 second. So we try example number 1. We writing the square root of a negative number. So we write x square root down here using the imaginary unit I. Okay, so how can we write this? So the square root of negative 25 now can be write as the square root of 25 times with r, right? Because the negative square root of negative 1 can be rewrite as r, right? You know that. Okay. Or I mean, you know what? Let me slow down a little bit. I can rewrite as square root of 25 multiplied by negative 1, right? And then I can rewrite as square root of 25 times square root of negative 1. And I know that this can rewrite as 25 multiplied by r. And then square root of 25 become 5r, right? So that is a reason why we have square root of negative 25 become 5r, right? Okay, so what about square root of negative 20? I can rewrite it as square root of 20 times with, you know, r. Okay, so I just want to make it become like shorter because you guys know that a negative 1 become r, right? So now how can I simplify? So for the square root 20, you know that square root of 20 can be rewrite as square root of 4 times square root of 5. So I will rewrite it as square root of 4 times square root of 5 times r. And everyone should know that square root of 4 is going to be equal to 2 times square root of 5 times r. And if I want to make it nicer, I can rewrite as 2i times square root of 5. Okay, so that's going to be the answer of B. Okay, so let's move back. We also learned about addition and subtraction and multiplication. Okay, so let's talk about addition and subtraction first. In order to add a subtract complex number, what we do is we add or subtract the real part and then add or subtract the imaginary part. Okay, so as you see over here, for the addition, you see we have 3 plus 6i plus negative 1 plus 2i. So what I do is I'm going to try to add the real part, which is 3 plus with negative 1. And then I'm going to add the imaginary part, which is 6i plus 2i, right? So that's the reason why I have 3 plus negative 1 and plus with 6 plus 2 and I'm going to have the answer as 2 plus 8i. And for the subtraction over here, you can see that I do also the same as to the real part, right? So I take 2 minus 1, right? And then I take negative 5i over here and minus for the 4i. So we give us like negative 5 minus 4, right? And then I have equal to 1 minus 9i. Okay, so maybe let's do some example to practice, right? So for the first column, which is addition, I have, I'm gonna do, you know what? I'm gonna open the parentheses so everyone can, you know, follow easily. So I have negative 7 plus 2i and plus with 3 minus 4i, right? I open the parentheses because right now it's addition, so there's nothing changed. So now make sure real part go with real part, imaginary go with imaginary. So negative 7 plus 3, and then I add with 2i minus 4i. So the answer should be negative 7 plus 3 gonna be negative 4. And then the imaginary gonna be 2i minus 4i. We're gonna give me minus 2i, and that should be the answer for this problem, right? Move to the you know what? Let me maybe okay. Move to the next problem. This is a subtraction, right? Let me open the parentheses in here. So I have 3i and minus 4, okay, 5, and add with I, because the negative, because the subtraction, you want to change all the thing inside of the parentheses. Okay, so now I have, you know, imaginary with imaginary. The real one just start first. So only -5 plus 3i plus I. That's give me -5 plus 4i. So that's gonna be the answer of this example. Let's move to multiply the complex number. So how can we do multiply complex number? We similarly to the way of FOIL, or I mean to distribution, is used to multiply binomials. Then apply the probability that, you know, I square going to be equal to -1. You guys should notice that the square root of -1 equal to I, right? So when you square both hand side, you will have -1 equal to I. So that is the reason why I have the probability at I squared equal to -1. Okay, so come back. So let's do an example. Let's take a look at the example over here that I have here for you guys. So let's say -1 plus 2i multiplied with 3 plus I. What we do is, by FOIL is take the -1 multiplied by 3, right? And then -1 multiplied by I, right? After that, you're gonna have like positive 2i multiplied by 3 and positive 2i multiplied by I. So down here it's give us like -1 times 3, right? Plus -1 times I plus 2i times 3 plus 2i times I. And then what we do? What we have? -1 times 3 gonna be -3, and -1 times I gonna be -I plus 6i, right? Plus 2i squared, right? Okay, so now simplify. So the first term just going to be real part. So -3, that's good. And then -I plus 6i going to be 5i, right? And then 2 times I squared going to change to be 2 times -1, right? And finally, you should combine the real number, -3 minus 2 going to be -5 and plus with 5i. That is very simple, right? But let's see how can we do this one. Okay, so we have 2 times 1 and then 2 times 4i. Okay, so let's write 2 times 1 plus 2 times 4i, right? Okay, so what next? -3i times 1, -3i times 4i. Okay, so -3 times 1 gonna be -3i. -3i times 4i gonna be -12i squared. Okay, so now let's simplify this. I have 2 and I plus with 8i, I minus 3i, and I minus with 12 times I squared change to be -1, right? Okay, so let's have a simplified step. Have 2 stay plus with 8i minus 3i going to be 5i, right? And then this minus 12 times negative 1 going to be plus 12, right? So finally, simplify going to have 14 plus 5i. This is going to be the answer of this problem. Okay. Okay, so let me see. All right, so let's move to the next problem. Actually, move down here. Okay, so again, I'm gonna follow at 5 times 5, right? And then, oops, 5 times 2i. So 25, and then plus 10i, right? And then I have negative 2i times 5, and negative 2i times 2i. Gonna give me negative 10i minus 4i squared. Okay, so simplify, you have 25, 0, and then minus 4i squared. Okay, so actually, you know what? 4i squared can be rewritten as 4 times negative 1. And then you have 25 plus 4, and that's give me a 29. This is a real number, right? So notice that multiplying complex number could give you, okay, note that I'm gonna say product of two complex number can sometimes give a real number. Okay. Okay. So we gonna learn about calculating power of I. Right? So you're gonna follow the powers of I rule in here as the value of I to the power n can be found by dividing n a positive integer, right? The power n is a positive integer by 4. And if the remainder is r, then in going to equal to I to the power r. So note that in here, some special cases such as I to the power 0 going to be just equal to 1. I1 going to be equal to I. And I square going to be equal to negative 1. And I to the power third will be equal to negative I. Okay, so so let's have an example for the different for the power I to the power n, and how can I convert it to become a I to the power r. What is that going to be, right? So we know that, so note that 9 divided by 4 will be equal to what? Equal to 2. Remainder 1. So the remainder is 1. So I can rewrite it as I to the power 9 can be rewritten as I to the power 1. which is equal to I. Okay. Okay, so equal to I. Okay. So what about I to power 19? Okay. Let's do it. And we know that 19 divided by 4 going to be equal to what? Say 4 times 4 is 16. So 4 remainder is 3. So I have I 19 equal to I to power third. And I to power third can be rewritten as negative I. So let's just circle the answer. Okay. What else? Okay, so oops. So now let's do I to power 40. So I have note that 40 divided by 4 going to be equal to 10. Remainder 0. So that give me I to power 0. I mean I 40 will be equal to I to power 0 will equal to 1. Okay, everything look good. And now we just gonna move to the finding complex conjugate. So let's take a look over here. So what is a complex conjugate? So the conjugate of the form A plus BI is just A minus BI, like similar with the conjugate last time we learned, right? So so let's have some examples such as like 3 minus 5i. It's gonna give me the conjugate gonna be 3 plus 5i. Okay. And for the 2i, I'm gonna get the conjugate is negative 2i. Okay, because in here, remember that's the complex number for 2i is 0 plus 2i, right? So the conjugate is gonna be 0 minus 2i. So okay. All right, so let's move down here and see how can I find the complex conjugate, right? So this one, problem A, I have 5 plus 3i. So I can have the conjugate easily is 5 minus 3i. Okay. So what's the answer? Okay, what about conjugate of negative 2 minus I? So easily you're gonna guess conjugate is minus 2 plus I. That's the answer. Okay, so maybe I have to make this one smaller a little bit. Okay. So now I have minus 4i, and I'm looking for the conjugate bit. So I would like to convert it to be in the general complex form, such as 0 is real part minus 4i, right? So the conjugate is 0 plus 4i, which equal to 4i, and that's gonna be the conjugate of negative 4i. Okay, so what about now? I have d equal to negative 6. that could be a little bit different with what we have before, but try to think about, like, you know, convert it to be in complex general form. So you have -6 plus with the imaginary part. In here you don't have I, so you're gonna write as 0i, right? So 0i to 0. So so then the conjugate is -6 minus 0i. But minus 0i is just 0 again. So then the answer should be just -6, right? So so a real number, conjugate a real number is so conjugate let me see, conjugate a real number is itself. Okay. Okay. Now we did learn about addition, we learned about subtraction and multiplication. Now let's talk about dividing. Okay, I mean division. Sorry, and dividing complex number. So in order to do dividing complex number, let's move off. If I have over here. Okay, so division over here. To simplify a quotient, multiply numerator and denominator by the complex conjugate of the denominator. So then, and then you simplify the expression and write it in the standard form as a plus bi. So let's do an example over here. What you are having as 10 divided by 1 plus 2i. So what you're going to do is you multiply by conjugate of the bottom, which is 1 minus 2i. You multiply by it for the denominator and the numerator. So you're going to get like 10 minus 20i over, you know, it just skip a step. And the bottom can be, you know, rewrite as 1 square minus 2i square. This it is apply the different of a square formula, and then that's gonna give you number 5, because you have 1 minus 4. 1 minus 4i square, right? 4i square gonna be 1 minus 4 times -1, right? So that's give me 5, and then you have you're gonna simplify to become 2 minus 4i. Okay, so let's have some example down here and see how can I do, how can I handle this one, right? Okay, so what I do is I have to multiply both top and bottom. Top is here, and then multiply by the conjugate at the conjugate of the numerator. So what is conjugate of 3 minus I? It is 3 plus I, right? And 3 plus I have to multiply both denominator and numerator with this guy. And now for the bottom, I will apply the difference between square, right? The formula for that. So I have 3 square minus I square. For the top, I'm gonna use a FOIL method, or just gonna distribution for that. So 2 times 3 gonna be 6, and then 2 times I gonna be plus 2i, and then positive 3i multiplied by 3 gonna be 9i, and then positive 3i multiplied by I gonna be positive 3i squared. So now let's simplify. I have top becomes 6 plus 11i, and then plus with 3 times I squared, which is minus 3, right? I squared is -1, so just gonna change it, become -3, and bottom give me 9 minus I squared, which is just -1. right? And then you will have 6 minus 3 will become 3, and then plus with 11, everything divided by 10. Okay, so so if I want to write it in the form at you know, at the complex form, so I would like to write the real part first, and by split these two become 3/10 and with 11/10 and I like to split it, become I mean, using the using the additional fraction or additional rational, so you can have, you know, this form as a general complex form, right? Because they need to have separate the real part and the imaginary part. Okay, so move to the next problems. I could I have 4 divided by 2i. So in here, you should just keep, you know, keep follow. My first step is multiply with the conjugate of the denominator. So I have 4/20, sorry, 2i multiplied by, okay, so what's the conjugate of 2i? It is negative 2i, right? And then negative 2i. Okay, so it's give you as 4 times negative 2i will be negative 8i. And the bottom give you negative 4i squared. And okay, so so now you have minus 8i at the top, but I'm gonna give you negative 4 times negative 1 gonna be 4, right? And actually, you know, you can cancel the 8 and the 4 over here, and you get the what? You get the negative 2i only. Okay, so and if you you want to write exactly in the form of the complex, you're gonna write 0 and minus for the 2i. So that's be the formula. Okay, so is there anything else? Nothing. Okay, so I'm gonna start the session 10.7 here. Next week we're gonna have the review exam and the exam and the midterm, right? So please practice on the review exam to make sure you can handle the exam. Let me know if you have any question about the review exam or the exam. And I will see you later. Bye.